Hello friends, welcome back to my channel. I am Pavitra Kumbargaud. This is the first session for the Differential Calculus 1. The topic is successive differentiation. To begin with, one should know some standard notations for the differentiation. If I consider y is equal to f of x be any arbitrary function, then differentiating with respect to x, you will get the first order derivative of y with respect to x, that is denoted by dy by dx or y dash or y1 or capital dy. Here capital D is called as differential operator, which is d by dx. If I differentiate first order derivative again with respect to x, you will get the second order derivative of y, which is denoted by d square y by dx square or y double dash or y2 or d square y. Similarly, if I differentiate n minus 1th order derivative of y one more time, you will get the nth order derivative of y with respect to x, and it is denoted by dny by dx raised to n or yn or dny. So, the process of finding second and higher order derivatives is known as successive differentiation. So, in this session, we are finding the nth order derivative for some standard functions. To begin with, I'll consider the first function y is equal to e to the power of ax. So here what we will do is, find the sum derivatives y1, y2, y3. Based on those samples, we are concluding with the nth derivative. So differentiating with respect to x, so you will get y1 is equal to, differentiation of e power ax is e to the power of ax into differentiation of ax is a. Here I have applied the chain rule. So that is a into e to the power of ax is the differentiation for y is equal to e to the power of ax. So differentiate one more time, you will get y2 is equal to, here a is constant, differentiation of e to the power of ax is e to the power of ax into a. So a into a is a square into e to the power of ax. So differentiate one more time, we will get y3 is equal to, here a square is constant, differentiation of e power ax is e to the power of ax into a. So therefore y3 is equal to a square into a is a cube into e to the power of x. So therefore if I continue like this, we will get yn is equal to, y1 contains a into e to the power of ax, y2 is a square into e to the power of ax, y cube is a cube into e to the power of ax. So therefore yn is a raised to n into e to the power of ax. So this is the nth derivative for e to the power of ax. So move on to the next function. The second one is, if I consider y is equal to a to the power of mx. If y is equal to a to the power of mx, what is the nth order derivative? You know that if y is equal to a to the power of x, so what is y1? What is the differentiation of a power x? So that is a power x into log a, right? So therefore differentiating with respect to x, you will get y1 is equal to a to the power of mx. Differentiation is a to the power of mx into log a into differentiation of mx is m. So y1 is m into log a into a to the power of mx. So differentiate one more time, we will get y2 is equal to m into log a is constant, correct? Differentiation of a power mx again is a power mx into log a into differentiation of mx is m. So m into m is m square, log a into log a is log a whole square. So that I will write m into log a whole square into a to the power of mx. So this is the second derivative. Find out the third derivative. So y3 is equal to m into log a whole square is constant. Differentiation of a power mx is a to the power of mx into log a into differentiation of mx is m. So that is equal to m square into m is m cube, log a whole square into log a is log a whole cube. So therefore m into log a whole cube into a to the power of mx. So this is the third derivative. If I continue like this, we will arrive with the nth derivative. So therefore yn is equal to m into log a. So y1 contains m into log a raised to 1. y2 is m into log a whole square. y3 is m into log a whole cube. So therefore yn is m into log a whole raised to n into a raised to mx. So this is the nth derivative for a raised to mx. So next move on to the next function, that is polynomial. If I have considered the polynomial, then what is the nth derivative? So that is third one. If I consider y is equal to x plus b whole raised, x plus x plus b whole raised to m. So find the nth order derivative. So here I will consider m is greater than or equal to n. Always m is greater than or equal to n. If it is m is less than or n is, that becomes 0. Okay, so differentiating with respect to x, we get y1 is equal to, so differentiation of x raised to n is n into x raised to n minus 1, right? So here m into ax plus b whole raised to m minus 1. So this is into differentiation of ax plus b is a. So that is equal to a into m into ax plus b whole raised to m minus 1. So find out second derivative. y2 is equal to a into m into is constant, differentiation of ax plus b whole raised to m minus 1 is m minus 1 into ax plus b whole raised to m minus 1 minus 1 is m minus 2. So this is y2. So similarly y into a into ax plus b differentiation is a. So that is equal to a into a is a square into m minus 1 into ax plus b whole raised to m minus 2. So find out y3. So similarly, if I differentiate one more time, y3 is equal to a square is constant, m is constant, m minus 1 is constant. Differentiation of ax plus b whole raised to m minus 2 is m minus 2 into ax plus b raised to m minus 2 minus 1 is m minus 3 into differentiation of ax plus b is a. So that is equal to a square into a is a cube, m into m minus 1 into m minus 2 into ax plus b whole raised to m minus 3. So if I continue like this, you'll get the nth derivative. So that is yn is equal to, so see here, first the constant term, a term, y1 contains a raised to 1, y2 is a square, y3 is a cube. Similarly, yn is a raised to n. So y1 is m, y2 is m into m minus 1 lesser than that. y3 is m into m minus 1 into m minus 2 up to minus 2. m into m minus 2, m minus 1, m minus 2. So similarly, yn contains m into m minus 1 into m minus 2 and so on, m minus 1 lesser than, that is n minus 1 into ax plus b whole raised to, so here y1 is m minus raised to m minus 1, y1 is raised to m minus 1, y2 is raised to m minus 2, y3 is m minus 3. So therefore it is m minus n. So this is the nth derivative for a polynomial. If it is negative, if m is negative, that case, so I will consider the next function, that is fourth one, y is equal to 1 divided by x plus b. So this can be written as x plus b whole raised to minus 1. So what is the nth order derivative? So differentiating with respect to x, you will get y1 is equal to, what is the differentiation of ax plus b whole raised to minus 1? So that is minus 1 into ax plus b whole raised to minus 1. Minus 1 is minus 2 into differentiation of ax plus b is a. So that is equal to minus 1 into a divided by ax plus b whole square. So find out y2. So next, y2 is equal to, so minus 1 as it is, a is as it is, differentiation of ax plus b whole raised to minus 2 is minus 2 into ax plus b whole raised to minus 2, minus 1 is minus 3 into a. So this can be rewritten as, so that is equal to minus into minus, it is plus 2 into a square divided by ax plus b whole raised to 3. Now find out one more differentiation. y3 is equal to, y3 is equal to 2 is constant, a square is constant, differentiation is minus 3 into ax plus b whole raised to minus 3, minus 1 is minus 4 into differentiation of ax plus b is a. So that is equal to 2 into 3 is 6, a square into a is a cube into 6. So minus is there, minus divided by ax plus b whole raised to 4. If I continue like this, so find out the nth derivative. So therefore yn is equal to, so continue like this, yn is equal to, see here y1 contains negative, so y2 is positive, y3 is negative. So when it is even number, it is positive, when it is odd number, it is negative. So that can be written as yn is equal to minus 1 whole raised to n into, so now here constant term, so here 1 into 1 is there, so there is 1 factorial, this is 2 factorial. Next 6 can be written as 3 factorial, y1 is 1 factorial, y2 is 2 factorial, y3 is 3 factorial, similarly y4 is 6 into 4, that is 4 factorial. So therefore it is 4n factorial into a raised to, so a raised to, here it is y1 is a, y2 is a square, y3 is a cube, similarly yn is a raised to n whole divided by power ax plus b whole raised to, here y3 is 4, y2 is 3, so therefore it is n plus 1. So this is the nth derivative for 1 divided by ax plus b. So move on to the next function, logarithmic function. So that is fifth one, y is equal to log ax plus b. So you know the differentiation of log x. Differentiation of log x is 1 by x. So find out the y1. y1 is equal to log x differentiation is 1 divided by ax plus b into a. Differentiation of ax plus b is a. So therefore differentiating one more time, y2 is equal to, here a is constant, so differentiation of 1 divided by x plus b is, so minus 1 divided by ax plus b whole raised to 2, right? Same one. 1 by x differentiation is minus 1 by x square. So that is equal to, into differentiation of x plus b is a. So therefore, so that is equal to minus 1 into a is a square divided by ax plus b whole square. So find out the next differentiation. Y3 is equal to, so y3 is equal to, here minus 1 is constant and a square is constant, differentiation of 1 divided by x square. So that is minus 2 divided by ax plus b whole raised to minus 2 means 2 minus 2 plus 1 is 3 into differentiation of ax plus b is a. So that is equal to minus into minus, it is plus 2 into a square into a is a cube divided by ax plus b whole raised to 3. So the next one, if I differentiate one more time, we will get y4 is equal to 2 is constant, a cube is constant, differentiation again it is minus 3 divided by ax plus b whole raised to 4 into a. So that is equal to a into, so minus 6 into a cube into a is a raised to 4 divided by ax plus b whole raised to 4. So this is the y1. So I will generalize it now. So y1 contains positive, y2 is negative, y3 is again positive, y4 is negative. So when it is odd number it is positive, when it is even number it is negative, right? So this can be written as yn is equal to, so minus 1 whole raised to, I will write 1 lesser than it, n minus 1. When it is even number it is, when it is y1 it is positive, y2 is negative. So when it is even number it is negative, so then it is positive. So next, factorials. So this contains constant 1, so that is, we can write it as a 0 factorial also, because y2 is also 1. This is 0 factorial, this is 1 factorial, y2 is 1 factorial, y3 is 2 factorial, and y4 is 3 factorial. So therefore sorry, 1 lesser than that factorial. So that is equal to, we'll get n minus 1 factorial into a raised to. So a raised to, so see here y1 contains a raised to 1, y2 is a square, y3 is a cube, y4 is a raised to 4. So that is a raised to n. So this is a raised to n. So whole divided by ax plus b whole raised to. Now, so ax plus b whole raised to 4, y4 is 4 and y3 is 3. So therefore it is ax plus b whole raised to n. So this is the mth order for the logarithmic function. So if I consider the trigonometric functions, let me check with the trigonometric function. So that is, the number is 6th one. So 6th one, y is equal to sine ax plus b. So differentiate. So y1, what is the differentiation of sine ax plus b? So that is cos. Differentiation of sine is cos. That is cos ax plus b into a. So that is equal to a into cos ax plus b. So see here, if I go continue like this, differentiation of sine is cos. Similarly, differentiation of cos is minus sine. So one time it is becoming sine function, another time it is cos function. So the generalization becomes so difficult here. We can, instead of that, we can write a into cos function can be written as sine pi by 2 plus theta. Theta here is ax plus b. Sin pi by 2 plus theta is cos theta, right? So therefore I have written, instead of cos, I will write sin pi by 2 plus ax plus b. So this is y1. So differentiating one more time, y2 is equal to, a is constant here, differentiation of sin, again it is a cos pi by 2 plus ax plus b. So similarly, this is also, I can write it as a into sin pi by 2 plus theta. So pi by 2 plus pi by 2 is 2 pi by 2. So 2 pi by 2 plus ax plus b. So into a, I will lost out a. So a into a is a square. So now y3 is equal to, so a square is constant, differentiation of sign, again it is a cos 2 pi by 2 plus ax plus b into differentiation of 2 pi by 2 plus ax plus b is a. So that is a cube into, this can be written as a sine function, 2 pi by 2 plus pi by 2 is 3 pi by 2 plus ax plus b. So this is y3. If I continue like this, yn is equal to, so therefore yn is equal to a raised to, y1 is a into, y2 is a square, y3 is a cube. Similarly yn is a raised to n into sine, y1 is 1 pi by 2 plus theta, means ax plus b. y2 is 2 pi by 2 plus ax plus b. y3 is 3 pi by 2 plus ax plus b. Similarly, this is n pi by 2 plus ax plus b. So this is the nth derivative for the sine function. If it is a cos, that is also same. If it is a cos, differentiation of cos is minus sine theta, right? So minus sine theta can be written as cos pi by 2 plus theta. Cos pi by 2 plus theta is minus sine theta, right? So similarly in the same line we can derive for the cos. So that I will write it as a directly here. So the seventh one is nth derivative if y is equal to cos ax plus b, the same line. So yn is equal to a raised to n cos n pi by 2 plus ax plus b. So this is the nth derivative for the cos function. Cos and sine almost are similar. So now move on to the next one. If I consider the product of two functions, exponential and trigonometric, so that is 8th one. If I consider y is equal to e to the power of x into sine bx plus c. So if it is a product of two functions, so let me check with the first derivative. So y1 is equal to, so here I have to apply the product rule. So what I will do, differentiation, what is the differentiation of e to the power of x? A into e to the power of x into sine bx plus c. So I've kept sine bx plus c as it is. Differentiation of e to the power of x is a into e to the power of x, product rule. So plus, I will write e to the power of x is constant, means as it is. Differentiation of sine is cos bx plus c into b, right? So apply the product rule here. So what is common here? E to the power of x is common, right? Into, so a is left in the first function, a into sine bx plus c plus, here it is b cos bx plus c, correct? So here if you observe here, so this is the product function. So here y1 contains how many terms? 1, 2 terms. If I differentiate one more time, y2 contains, again here you have to apply the product rule, you will get two terms, and here also you will get the 2 terms. So that is totally 4 terms. So y1 contains 2 terms, y2 contains 4 terms. Similarly, y3 contains 4 into 4 means 8 terms. So therefore, instead of that, I will substitute the a is equal to cos theta and b is equal to r sin theta. So here I have applied the substitution method. A is equal to r cos theta and b is equal to r sin theta. Right. So find out r and theta in terms of AB. So if I square and adding, you will get a square plus b square is equal to r square into cos square theta plus r square into sin square theta. So that is equal to r square is common. Sin square theta plus cos square theta is 1. So therefore a square plus b square is equal to r square. So therefore r is equal to root of a square plus b square. So if I divide these two, so b by a, so divide b by a. So that is b by a is equal to r sin theta divided by r cos theta. So r get cancelled. So therefore b by a is equal to, so sin theta by cos theta is tan theta, implies theta is equal to tan inverse of b by a. So substitute, and this is r is equal to. Okay. So here what I will do, so substitute a is equal to r cos theta and b is equal to r sin theta in the above equation. So here I will not substitute, that is no use here. So therefore here and here I will substitute a is equal to r cos theta and b is equal to r sin theta. So equation becomes y1 is equal to e to the power of ax is as it is into, so a sin bx plus c. A is r cos theta, into sin bx plus c, correct, plus a sin bx plus c, then b cos bx plus b. B is r sin theta, sin theta into cos bx plus c. Okay, so this is the y1. So here r is also common. The next line, y1 is equal to, so y1 is equal to, r is constant, e to the power of ax is constant. So you will get cos theta into sin bx plus c plus r is constant, I have taken sin theta into cos bx plus c, right. So now, so therefore y1 is equal to r into e to the power of ax as it is here, sin a cos b plus cos a sin b, right. So that is equal to sin a plus b. So that is sin bx plus c plus theta, right. Sin a plus b is sin a cos b plus cos a sin b. So this is the y1. Correct. So if I continue like this, so again, so substitute differentiate one more time, then substitute a is equal to that and b is equal to that, then you will get the same. So therefore similarly you can try directly here. Similarly y2 is equal to here r square into e raised to ax sine bx plus c as it is, plus you will get one more theta, that is 2 theta. So therefore you will get arrive with a yn. So therefore yn is equal to r raised to n e raised to ax into sine bx plus c plus n theta. Right. So substitute r and theta. What is r is equal to? What is r is equal to? Root of a square plus b square. And theta is tan inverse of b by a. So substitute those value. You will get yn is equal to r is root of a square plus b square raised to n e to the power of ax sine bx plus c plus n into tan inverse b by a. Okay, so this is the nth order derivative for the e to the power of ax into sine bx. Similarly, in the same line for the last one, if y is equal to e to the power of x cos bx plus c. So this is also same. Yn is equal to root of a square plus b square raised to n e to the power of ax. Here you will get cos bx plus c plus n tan inverse b by a. In the same line we can find for e to the power of ax into cos bx plus c. Okay. Thank you for watching my videos. Please like, subscribe and press the bell icon to get the notification early. Thank you so much.